3 decades after scientists first came up with the idea, the world's most ambitious physics experiment has finally begun. Deep beneath a mountain in Switzerland at a cost of billions of dollars, some of the world's most brilliant brains are trying to discover what happened in the instant after the Big Bang. It's an attempt to explain nothing less than the very origins of the universe. The CERN project has had its teething problems and is running 2 years behind schedule. But this evening, a team of researchers finally fired up the world's most powerful atom smasher.
It's the biggest scientific project ever undertaken, and arguably the most unusual. Nearly 2 decades in the making, costing almost $7 billion. All this to discover how the universe was born.
It is just curiosity. This is this is completely crazy. This is man peering into the depths of time, into the depths of the universe, just trying to work out why. And, fascinating questions, difficult answers.
The Large Hadron Collider, or LHC, is near Geneva on the border of France and Switzerland. It's a vast underground laboratory within a circular tunnel about 27 kilometres around. 100 metres down is the most powerful atom smasher ever built. Today, it was fired up for the first time. Particles are now being beamed around the track in opposite directions, building up to almost the speed of light. They'll be smashed together to create conditions like the immediate aftermath of the Big Bang. It's at this stage that scientists hope to work out how the universe came to be. It sounds out of this world, and those involved know it. This is CERN laboratory trainees' creative take on the massive collider. A rap song to make the concept of the collisions cool. This song explains how 4 massive magnets will track down the particles released after the collisions. The hope is that it will explain dark energy and dark matter that are believed to make up most of the universe.
We now know that we can see only 4% of our universe. 96% is a complete mystery to us today. We hope that the LHC will help us to elucidate where that 96% is coming from.
But could this bold experiment to discover the secrets of the universe spell the end of the world as we know it?
There are far more powerful particles that are flying and hitting the Earth all the time, and have been since the Earth was created, and the Earth hasn't been destroyed yet. So we're not doing anything that's not out there in nature. All we're doing is carrying out these collisions in a controlled way so we can study them.
If there is any risk involved, these scientists say it's worth it. Melanie O'Connell, World News Australia.
And Australian scientists have been keenly involved in that project. A short time ago, I spoke to Melbourne physicist Jeff Taylor about their contribution.
The Australians have been working on this project, Anton, now for nearly 2 decades. And we've initially were part of the development of the detectors, which had to be made enormously more robust and powerful than existed back then to be effective in the foreseen environment of the LHC. So Australia was involved in developing silicon detectors, and since that time we've more recently, now that the detectors are all installed and operating, the group has been developing computer capability so that when the data comes out of the Atlas experiment, we can be ready to analyse it and dig out the results.
Jeff, they're calling it the search for the God particle. How does that help us understand our 3-dimensional world?
It's a good question, and the God particle is a great name for it. It's the Higgs boson in scientific terms. We understand a lot about the particles of nature, the matter around us, the matter that we're made of, the matter that we're standing on. We have a very good understanding of this stuff. And it's built upon a mathematical model which uses a symmetry where the forces of nature can be described accurately. And of course, with all symmetries, the beauty is in the symmetry. However, the real spice, I guess, is with the slightly broken symmetry. And in this case, the symmetry doesn't say anything about the mass of the particles which we're made of. Whereas this breaking of symmetry through a mechanism introduced by Peter Higgs, which may or may not be correct, it allows us to explain the mass of particles.
And what about the dangers, Jeff? There have been some opponents to this project who say that when you start messing around with creating black holes, that it creates a potential danger.
Yeah, the word black hole conjures up a very dramatic kind of a possibility. The centre of our galaxy is powered by a black hole. What gets forgotten about is that we're only going to be able to create mini black holes, if any at all. It would be a fantastic discovery because it would be telling us something about gravity. But the mini is extremely important. The only black holes we'll be able to create are tiny, tiny black holes, and they'll evaporate almost as quickly as they're created.
We look forward to, with great interest, as the project gets underway. Thanks for joining us tonight.
Thank you, Anton.